In this lecture, we're going to go over what are sets, how do you describe sets, what are complements of sets, how can you put them together, and then pictorially what does it look like. So we're going to talk about sets. So first we need to know is what is the definition. So a set is a well-defined collection of objects. These objects have a special name. These objects are called elements. These objects are called elements. There's also one set that we do need to define, and that's called the empty set. So typically when we talk about sets, we'll give a capital letter, and we'll say A is the set, so curly braces. And maybe we'll say this time A is the set containing the elements A and B. So that's how you define what a set is. There is a special set, and that's called the empty set. The empty set is exactly what it sounds like. It is the set that contains nothing, and it has a special notation. That's the empty set. This is the set with nothing in it. Also, speaking of notation, whenever you want to say that an element is in a set, use this term. So this is the notation we're going to use. It's kind of like an E with a little line between it. This means is a member of. So in our set, we had A was the set containing the elements A and B. So what we could say is that A is a member of big set A and B is a member of big set B. So this little E means is a member of. Now that's not to be confused with a subset. So here's a different definition. So a subset is a smaller set contained in the larger set. And this also has special notation, much like with the is a member of. A subset we write this way. So kind of like, you can think of it as less than or equal to sign. This is almost like it's a smaller set. So for example, let's let my first set be A, which is going to be the letters A and B, like we've been using. And then let's have the set B, which is the set A, B, and C. So those are my two sets that I'm going to work with. What I can do is, since every element of A is also in B, I say that A is a subset of B. Now B is not a subset of A because every element of B is not in A. So C is not a subset. C is not an A, so therefore B is not a subset of A. So you could say that since C is not in A, B is not a subset of A. So if you want to say that one set is a subset of the other, it just means that each element in the smaller set is also in the larger set. Now there are a couple different ways to define sets while we're doing this. Let's talk about the set of the numbers 1, 2, 3, 4, and 5. If we were trying to think of a different way to describe this, what we could do is define it explicitly. So a different way to define this is to say, this is the set of all x, so x is our variable. Then we draw a line. Now this line means such that something is true. Now this something is that x is between 1 and 5. These are the same set. This is just defined a little bit differently. Here I've listed out the elements. Here I've defined what the set looks like. But they're the same thing. Alternatively, let's say my set A is going to be the numbers 2, 4, and 6. Now I could write out the members of it, or I could say this is the set of all x such that x is even and x is between 2 and 6. So you could write it out that way. You just want to be comfortable with both of these ways to to write sets. Let's do one more. Let's say that B is the set of all numbers, 4, 5, 6, and it goes on forever. So this is an infinite set, meaning that I have tons and tons of numbers in here, infinitely many, in fact. How could I write this? You could say this is the set of all x, such that x is greater than or equal to 4. So, alternately, that's how you could write it. Any one of these is fine. There's no right way to do this. There's no wrong way to do this. Completely up to you how you write these. So, just be comfortable with both. Now, just like with numbers, we also have kind of different, like arithmetic operations with the numbers. We have operations with sets. So the sets that we have this subset. We can also talk about intersection and union. So these are operations with sets. So first one is intersection, which the notation here is an upside down U. So intersection of two sets is all the common elements. So if I'm talking about my set A is A, B, and C, and my set B is A and B, so I've switched the two from last time. What is their intersection? You would say the intersection, it's also a set. Make sure and say this is also a set. So what elements do these two have in common? Well, A is in both of them, and B is in both of them. So intersection is all of the common elements. Here I have A and B. Second one is the union. Union is just a U. That's how we define it. Let's use our same example from before. The union just means to put all of the elements together, but don't repeat elements. So here, A union B, still a set. I'm going to write down everything that's in A, and then write down everything else that's in B. Well, I've already written down both of these elements, so that's just the union. So the union just means put them all together. Now the third operation is called the complement. Now the complement is going to be defined as either A bar or AC. Sometimes you'll see it both ways. For the complement though, you need a universal set. So the universal set is kind of the bigger set, or the bigger picture. So let's say that my universal set is the numbers 1 through 10. So that's my universal set. This is the largest set possible. So this is everything. This is my universal set. And I'm looking at the set A, which is 2, 4, and 6. What is A complement? So A complement is everything that is not in A. So I look at my universal set and I say, what's in my universal set but not in A? So here it'll be 1, 3, 5, and then 7 through 10. So this is everything that was in the universal set but not in A. Let's use the same universal set, but now let's look at B is the numbers 1 through 5. What is B complement? Well, B complement is going to be everything that's in my universal set but not in B. So this would be the set 6, 7, 8, 9, and 10. So that's how you do the complement. So it's everything in your universal set that's not in the set you're looking at. So B complement, everything that's not in B. A complement, everything that's not in A. So let's do a kind of a big example of this. Let's say that U, again the numbers 1 through 10. Let's say that A is numbers 2, 4, and 6. Let's say that B is the set of numbers 1 through 5. And let's say that C is the number 7. C is the set containing the number 7. So let's do a couple examples of this. First off, what is A union with C? So A union with C means we're going to take these two sets and put them together. So I'll have 2, 4, 6, and 7. Okay, what is A intersect B? So this is going to be all the elements where they overlap. So 2 is in both sets, so I'll have 2, and 4 is in both sets. Okay, what about C complement? So C complement means everything that's in the universal set, not in C. So that's everything except for 7. So 1, 2, 3, 4, 5, 6, 8, 9, 10. What about A intersect B complement? So we already know what A intersect B is. This was 2, 4, and I'm looking for the complement of that. So I'm saying, what's in my universal set that's not in this? So that would be 1, 3, 5, and then up to 10. And then lastly, what about A intersect C? So do these two sets have anything in common? Well, they don't, so there is none, so you would say this is the empty set. This is where the empty set kind of comes into play. This is whenever you have two sets where maybe the intersection is nothing, so you say it's the empty set, or the complement maybe is nothing, something like that. So that's where the intersection is equal to the empty set. So along with all of these sets, you can draw this in terms of a Venn diagram. Go on the next page here. So a Venn diagram is just a picture of how sets interact. So the way a Venn diagram works is that you're going to have one large rectangle. That's going to be your universal set. So this is kind of like, it's almost like the universal set is the world. This is everything that's possible. Then I'm going to have my sets kind of inside of it. This section here, that's where they overlap. That would be A intersect B. And then if I put them all together and shade them, that's A union with B. So let's do an example of a Venn diagram. Let's say that my universal set is again 1 through 10. Let's say that my set A is all of the even numbers. And let's say that my set B is 5 through 10. So 5, 6, 7, 8, 9, 10. Let's draw this in a picture. So again, I'm going to have my universal set. I'll have my two sets here. And you could do this with 3 sets. That's fine. So let's start with where does 1 go? Well, 1's not in either one of these sets, so 1's going to be out here. What about 2? 2 is in A, not in B. What about 3? 3 is in the universal set, not in either one of those, so maybe we'll put 3 over here. 4 is in A, not in B. 5 is in B, but not in A. Then what about 6? Well, 6 is in both of them, so 6 will go right here in the middle. 7's in B, not in A. 8 was in both. 9 is in B, and then 10 is in both. So this is the picture that we would have. Now from this, we can kind of read off fairly quickly. What is A intersect B? That would be this overlap here. So that's 6, 8, and 10. And then what is A union B? Well, that would be everything between the two. So 2, 4, 6, 8, 10, 5, 7, 9. So you can see how the Venn diagram works. It's just your two sets. This is going to be their intersection where they overlap. The complement would be everything outside of them. So for example, A union with B complement would be 3 and 1, so it's everything outside of the two. So this is just a way to pictorially show how your sets interact.